So, you want to become an expert at preventing arc flash. Well, before we look at how to prevent it, let's explore what arc flash is. An arc flash is an electrical explosion that happens on energized equipment. It could be an air conditioner, conveyor belt, or light bulb. When electrons move back and forth across a conductor, like a wire, a small area outside of that conductor is energized. Voltage can push those electrons off the conductive surface and onto atoms and molecules in the air. These atoms become ions because they have an electric charge. The air that is around us is a pretty good insulator to stop these ions from causing an explosion, but it's not perfect. If another conductor gets inside that energized area, a wrench, moisture in the air, dust buildup, or someone's hand, the electrons will travel through that new path. As the electrons push off between the conductors, an arc occurs. You see this every day on a micro scale when flicking on a light switch. The little spark inside the bulb is an arc. But on these larger scales, the arc between the two conductors creates heat. A lot of heat. Arc flashes can reach 35,000 degrees Fahrenheit, which is 4 times hotter than the sun. Depending on the voltage of the machine, workers up to 23 feet or 2 car lengths are in danger of second-degree burns. So, how do you protect yourself from one? The only foolproof way to eliminate the risk of an arc flash is to de-energize the equipment through lockout-tagout procedures. If you do need to work on energized equipment, you're going to need protection. Your entire body is vulnerable to an arc flash. But because we're a work glove company, we're going to look only at arc flash rated gloves. But these ratings apply for other personal protective equipment too. When choosing arc rated gloves, you need to look at the glove's arc thermal performance value, ATPV. ATPV is the incident energy needed to cause a second-degree burn. So, the higher the ATPV measurement, the more protective that glove will be. It's the temperature produced in calories per centimeter squared at a certain distance, usually 18 inches, from an arc flash. It's called incident energy because it's energy that isn't supposed to be released. But how much is 1 calorie per centimeter squared? If you were to hold your finger directly over the flame of a lighter for 1 second, that's 1 calorie per centimeter squared. It takes 1.2 calories per centimeter squared to create a second-degree burn. A second-degree burn means you'll have red, blistered, and swollen skin. So let's say you have a glove with an ATPV of 8.2 calories per centimeter squared. That means if the arc flash's incident energy is 8.2 calories per centimeter squared, you have a 50% chance of getting a second-degree burn. Those odds might not sound great, but imagine if you were given a 50% chance of winning the lottery. Suddenly, those odds sound pretty good. And think about it. Escaping an electrical explosion that is 4 times hotter than the sun with only second-degree burns is a bit like winning the lottery.